Welcome, everyone. I'm excited to guest moderate today's webinar. My name is Kelly Webb. I lead the field marketing team here at Keyfactor. I'll be your webinar host for the next 30 minutes, where we will explore the unique partnership between wolfSSL and Keyfactor and how their solutions together help build secure IoT devices at scale. Please advance to the next slide. I'm joined by an impressive crew here today. First, we've got well-known John Safranek, Senior Solutions Engineer at wolfSSL, along with Ellen Boehm, Keyfactor Senior Director of IoT Project Management. Just a few features to cover before we get started. Questions. If you have any questions, we do encourage them, so feel free to submit them at any time during the webinar, and we'll try to answer them at the end of the presentation at our Q&A. If we're not able to answer your question, we'll ensure that our team follows up afterwards. Poll questions. We're excited to launch poll questions on today's webinar. We'll take 2 short breaks to address 2 questions. This is just an opportunity for us to gather and share collective feedback. So look out for prompts throughout the webinar. We encourage full participation. Please advance to the next slide. Great. In today's webinar, we're going to cover a variety of topics focused around IoT device security, including the use of digital certificates, public key infrastructure, and embedded crypto libraries. Each of these pieces can in turn help device developers and manufacturers establish best practices when it comes to design, deployment, and management of their IoT devices throughout their lifecycle. All right, let's get started. Let me pass the mic over to John to kick off today's webinar.
Hi, I'm John Safranek with wolfSSL. I'm one of the senior developers with wolfSSL. We've been around since 2004, making cryptography and a TLS product. We'll be talking a bit today about our products that we do offer, wolfSSL, wolfCrypt, the FIPS engine inside the wolfCrypt, and then our pub sub system, wolfMQTT. We implement the MQTT, and then wolfboot, our secure bootloader, and that's. I'm gonna pass over to Ellen now.
Hey, thanks, John. So thanks for having me, guys. Keyfactor is a company that specializes in digital certificate lifecycle automation, and we offer a variety of products that you can see here on the screen that provide digital identities for connected devices, whether that's in the enterprise, whether that's for IoT devices that you manufacture. We can help customers with overall cryptographic management of keys and certificates. Now, this basically occurs, we offer a PKI as a service option, and our platform is really built around an open architecture that is highly scalable, is agnostic, and it's very extensible depending on what your exact use cases are. And excited today to be able to talk a little bit more about what the basics of PKI are and what we've leveraged from the enterprise space, right, and how we're taking that into IoT.
So we have an example demonstrating how wolfSSL and Keyfactor can fit together in a deployment system. Inside your IoT device, your application would be running with wolfSSL to provide network security, encrypted data channels, encryption of data at rest inside the device, and it kind of fits in between your app and the OS. It will talk to the your device, then would talk to the PKI agent orchestrator for Keyfactor. So I'm gonna.
Yeah. So adding on to that, kind of reiterating what John was saying, right? When it comes to the crypto that's in your device, you probably have multiple certificates or keys that need to be managed. And what we're showing here is with this PKI agent orchestrator that you can use that framework to create or re-enroll these IoT device certificates. You can also use that to create a private key for the device through on-device key generation, or to store other certificates that that IoT device trusts based on the root of trust that's been established. And Keyfactor agents here, utilizing the wolfSSL and curl libraries for cryptographic functions, will basically then connect securely to the internet back to that PKI and certificate automation platform that you see in the bottom right. And that platform is used for client cert auth and to do things like initial device identity provisioning, to do overall root of trust management, device commissioning, mutual authentication, and so on. And one more bit about the PKI agents and orchestrators. So Keyfactor offers them in multiple flavors. So POSIX-C is very popular with embedded developers, as well as we have an offering in Java. We have .NET for Windows, Android, and iOS. And we also offer a complete web API so that designers and manufacturers can get certificates onto the devices and perform commissioning or long-term cert management according to your use cases and the best way to implement it for your company. So here we want to touch a little bit briefly on the market. And I think this is pretty well known to most of us, and we've heard about this exponential growth of IoT devices. For example, we anticipated that by now we'd have about 20 billion devices out there, but in actuality, I think we're surpassing that and seeing more like 25 billion things. And many of these IoT things are being deployed into critical industries, including medical devices, industrial applications and control systems, and so on. And we all know, right, that the benefits of IoT devices are efficiency and functionality and analytics, but in order to really trust that that data is secure and at rest and in transit, like John was mentioning, we have to incorporate the proper security mechanisms around authentication and encryption so that that trust can be maintained. So speaking of authentication, we've all likely heard examples in the past where weak or hard-coded credentials have been shipped embedded in the firmware of IoT devices. And that was, the intent was in the right place, right, to build keys and certs into a framework to provide a level of security. But sometimes there's security loopholes that can be discovered, right, and taken advantage of. So we need to kind of prevent that. And then lastly, around the algorithm deprecation, we also hear about the threat of quantum computing coming, right? And the crypto that we build into our devices today is not going to be as strong as it can be in the future, especially when our devices are lasting for such a long time. And so having the flexibility to be able to update the crypto over time is something that's very important. So John, I don't know if you want to add a little bit more onto that one.
Just that wolfSSL is adding new ciphers periodically as they come out, and it is a moving target. So we try to stay on top of the new algorithms coming out and the new standards in wolfSSL and wolfcrypt.
Yeah, and I know at Keyfactor we've recently done a study analyzing 75 million RSA certificates that we found on the internet, and we discovered that about 1 in every 172 of them are vulnerable to attack due to poor random number generation. Okay, so those keys were found, a lot of them were found in embedded IoT devices. And in our lab testing, we were able to, using a single Microsoft Azure VM, break 250,000 RSA keys in under 18 hours. And that's just like with the power that we have today. So interesting things that we're kind of studying and doing on the side, but just, again, shows the importance of being able to be flexible and agile and be able to update things.
And good random numbers is a topic that we're very interested in at wolfSSL. Um, so one of the problems, one of the risks that people tend to have with using cryptography in their embedded device is device constraints. Crypto takes some memory. It takes processing. It takes time to work with the RSA and the public keys, and that's somewhere we at Wolf we target that. Those are the folks we're trying to help out, is those people with tight environments to build in. So we write wolfSSL and wolfcrypt in C and do heavy optimization. Another problem is also with the cryptography, weak authentication and encryption. Ciphers get broken, and it happens, and periodically you have to do an update. And we provide new algorithms with wolfcrypt, and then also help with secure booting using wolfboot. I guess Ellen.
Yeah, sure. So lastly, kind of on the operational side, we know that connectivity out in the field can be intermittent, right? So, and I'll talk about this in a little bit about how we handle offline devices and managing identities over time there, but it's really important to implement the right protocol to connect to those devices and the platform to handle that. And having technology that's architected so that your device can update those credentials when it comes online, and then also having a way to be able to update roots of trust in the events that equipment or industrial assets need to change hands. So we talk about different ownership. That's a case that we can handle if you've kind of set that root of trust up specifically to be able to who you're going to pass it over to. So I think we can go to the next slide. I'm going to transition over to Kelly. We've got our first poll question.
Absolutely. Thanks, Ellen. So like Ellen said, we're at the first poll question. Let's go ahead and read it. So how would you describe the current level of your security in your network embedded device? So it looks like the poll just got launched, and so go ahead and submit your answers. We'll give everyone about 30 seconds, and then we'll have John go ahead and explain the results. So it's multiple choice. My device is too small and slow for TLS and cryptography. My device runs Linux, so I'm okay. Or the third, I'm not quite sure. Alrighty, so it looks like the results are in. Go ahead, John, take the lead on explaining the results.
So a common question that I've received at some shows has been, you know, my product, I'm running a tiny processor, and I can't deal with RSA or crypto. But the problem in the world today now with embedded devices is, if you stick it on the network, you really need to be securing the connection. It just needs to be done. It's imperative. We try to help you with that. It's a it's our crypto library. We write it to be as small as possible. Unfortunately, things like RSA keys are huge. You can't get around that, but maybe you can your next design. If you're not quite sure, you're still in the design phase, you can, you should probably think about, you really should think about that, not probably. If your device runs Linux, yeah, you probably have the memory to handle this, handle cryptography, and you should definitely look at doing that. Okay.
Yeah, I think we could probably move on to the next slide, John.
So when developing your device, you're going to want to have unique IDs, and part of, most of the time these days people are using TPMs to store their private keys, and that is something to look at using. When you're putting it on your board, you're controlling the key. You can work the crypto library into your software design, and then when you manufacture, you are keeping track of your keys, and then need certificates and such. And that's where commissioning comes in.
Yeah, so I can take it over from here, John. So typically after the device has been manufactured, right, and you've decided to provision an initial identity at the device, then sometimes that IoT device gets packaged up and is sent to a distribution center, maybe waits on a shelf or a loading dock or something somewhere until the time where it needs to get installed in its end location. For example, if you have some sort of controller and it's going into a power substation and that's being built, it could be a couple of years before your device, which has been produced, actually is up and running. So that's the commissioning process that we talk about. And really, it's essential, again, to have a trusted user and a trusted device that they're using to be able to connect to that IoT device based on that root of trust that was established at the time that you manufactured it. Then that intermediary device and that technician, for example, can use that root of trust to communicate. And then kind of moving over to the lifecycle part of it, right, at any time that you need to do a firmware update, if you use a digital signature from that root of trust, then that signature verification can occur and will allow you to then have confidence and be able to install that firmware and then boot up the device. So that's where we get into that kind of secure boot that John mentioned. And then finally, kind of at end of life, if you have to replace any certificate or revoke any certificate for a simple reason, that needs to be an automated process, because when we make these devices that are out there for 15 to 20 years, you likely are going to want to put in a certificate policy that expires maybe 18 months to 2 years throughout, right? So you don't put a cert on your device that lasts for that long, because that's not really the best practice. So having a fail-safe method in order for you to be able to keep track of things and to update them, to set alerts and do it kind of automatically so you don't even really have to think about it. That's the power of using a lifecycle management platform. And then finally, just the common thread here we're showing in the arrow at the bottom is establishing that root of trust throughout all the steps of your process. So from when you're designing it to building it to using it, right, and end-of-lifing it. So we can transition to the next slide. Thanks. So PKI, we've kind of thrown this acronym around. It's really, if you're not too familiar, it's a framework and a fundamental security tool that is being used by most organizations today within their enterprise, whether they know it or not. And there's really strong recommendations that we're hearing and we're reading around the use of PKI, around the use of hardware roots of trust, and specifically asymmetric cryptography to fully trust IoT devices. So in the boxes below, you can see some advantages of PKI, and they really speak for themselves. It gives you flexibility, scalability, it's robust and has solid root key management, right? Especially when you design that PKI purpose-built for your industry, for you set policies around how you want to use it, how you want different product lines to be segregated, how you want different partners or customers to be able to interact with certain parts of your PKI. All of that can be customized, and that's what we do when we're kind of going into these design sessions with customers and figure out what's the best system for you. And then just ultimately, digital certificates they're not only cost effective, but they're efficient, and then they're lightweight and scalable. So that's why we've seen success in implementing PKI as an ideal fit for resource constrained devices, and then in high volume situations, you know, because think about managing millions of certificates in a manual way. It's just really there's you know, human error can occur, and there's benefits to having this be driven off of a software platform. So I think we've got our second and last poll question here. So I'll hand it over to Kelly.
Awesome,
again.
Ellen. Thank you. Appreciate that. Alrighty, so poll question number 2. Do you currently use PKI to create and manage secure digital identities for your IoT devices? If you want to go ahead and launch the poll. So the four answers we have is yes, no, but we're exploring, wasn't aware of the possibilities, or not sure it's a fit.
Okay. Well, yeah, I'll give it one more minute here. If you guys don't see the poll coming up, because I'm not seeing it on my screen, I'll just yeah, give it a minute here. Could be a Zoom thing. I know there's a ton of people working remotely these days, right? So, well, let's just keep going. So, kind of the way that I was going to talk about this question is, I was hoping to see some of you that are really kind of exploring or aware of the possibilities of PKI. I think, like I said, there's a lot of experience in the enterprise side with the enterprise IT organizations with using PKI. And I think that some people are becoming more familiar, which is great, because PKI has been the foundation of internet security for decades, right? Through the widespread the use of the TLS and SSL certificates. Now, with the emergence of more IoT devices and knowing that PKI is that solid framework, it's becoming more widespread and allows us to do strong authentication and encryption and integrity, right? You know, from design all the way through deployment, like we talked about. So I think we can go ahead and continue on. We've got a couple more slides here to talk about use cases. So here, I don't want to go through all of these because each one of these little icons here, we could spend a lot of time talking through for your specific business. But I must say that when I have conversations with our IoT clients, that there's a lot of consistent themes, okay? So on-device key generation, you know, being able to create the private key within the device so that it's never intercepted by anyone that shouldn't have access to it, and then be able to create the public key from that private key, and then only distribute that public key to people that you need to, and then use that for the authentication. Another one I'll highlight is that offline limited connectivity. I mean, this happens all the time, whether that's by design or unintentionally you have intermittent internet connectivity. What we always recommend is that if you bind your authentication and authorization to a hardware root of trust, you do that from the beginning. At that point, any device that is kind of built within that same trust chain can authenticate to the other one, whether they're connected or not to the internet. So for example, some IoT systems incorporate a mobile device or a tablet to interface with connected devices in the field. So let's say you've got a medical device that the patient is wearing, and then there is a mobile app that they connect to, and then that data from that mobile app needs to go to the cloud where their doctor or their clinician can check on their statistics and be able to give recommendations around how to change the settings, how to change the medicine delivered, and things like that. So any of that mobile device that's used, or the application in the cloud, right, are intermediate endpoints that are built from that same root, or have that same access in them, and that those devices that are used can talk back to the backend IoT platform, verify their identity, and also do the certificate signing request, which was originally generated at time of manufacturing in that IoT device, do the validation, process the certificate signing request, and then the certificate and the root of trust are returned to that IoT device. And all of that can occur through this intermediary technician laptop or a mobile app or something like that, right? So that's what we talk through when we get into the specifics around how your system works and what are the different levels where you want to embed authentication and encryption. So again, multiple use cases here. We can build out with sequence diagrams to kind of understand where and how to put in the certificates, how to create them, and how to exchange them. And I think some considerations here we show on the bottom. We kind of talk through most of them. I'd really just say, firstly, figure out where you want to set up your root, okay? So whether that's an internal PKI, you've got a public, offering, you've got a CA, you do PKI as a service. There's a bunch of different options that you can do depending on your organization and where you want to hold that root. And Keyfactor can kind of help discuss that with you. Secondly, again, where is the private key going to be stored? You're going to put it in a secure element. You're going to put it in a TPM, for example. And then also that provisioning and commissioning. Are you using a partner to do that? Are you doing that by, you have trusted people within your company? So all of that stuff you kind of have to map out. And then lastly, we talked about this before, but really, what is the recommended validity period for your certificate? What is the key size that you can fit in your device, but also, what is that algorithm that is best suited for, the current time period that you have right now, and then how do you need to be able to be flexible to update that in the future? So we can move to the next slide.
So, yeah, chip to cloud security, putting it all together. wolfSSL can help you with putting the embedded TLS library into your device and working the cryptography library in with your application. We can talk to TPMs to push some of the signing and whatnot for the TLS handshakes to the TPM, and work with microcontrollers with hardware key storage. We can help interface all of that with your device. Ellen?
Yeah, and so again, at this bottom layer, we're going to work up, right? The Keyfactor can integrate with wolfSSL for that end-to-end encryption. And the next thing that we typically see is around the IoT development platform, right? So oftentimes in the middle between the devices and the cloud platform is some sort of broader IoT management system that is driving things like device onboarding or registration, kicking off like firmware OTAs, maybe device revocation at end of life and things like that. And you got to make sure that your IoT development platform connects into your certificate management layer in order to be able to keep credentials up to date and relevant. And then finally up at the top, there's elements hosted in the cloud. Can include your overall hosted PKI if you choose to host in the cloud versus on your own premises. But then also can utilizing that certificate management software in your factories, in your operations center, giving access to those who need to actually manage it. Also be able to have it for audits, right? So there's likely more and more industries, I think, are going to start to have take a role in terms of having standards that are specifically around certificates and identities, and being able to show an audit log of who's accessed what certificate, whether it's been used for code signing or certificates that are actually just given out to your devices themselves. Having that audit trail to be able to keep track of all of that in a software platform is becoming more and more important. So really, the main point here is just that at all layers of the typical IoT network stack, the consistent thread tying things together is that root of trust, and how we have to build that into everything from your end device, right? And whether you're utilizing that TPM or a secure storage, picking those right crypto libraries, tying it into the intermediary IoT platform, and then any cloud servers that you're kind of using to connect into the system. So I think we move on to the next slide. So I think here we're just gonna want to wrap it up and leave you with this last reminder, kind of who wolfSSL is, who Keyfactor is, and how we kind of work together as an offering for very rich, set of crypto libraries, plus the PKI as a service and certificate lifecycle automation.
Fantastic. Ellen, thank you so much. John, thank you so much. We are coming at the bottom of the hour, so I do want to be sensitive of time. So if anyone does have to drop, thank you. I appreciate the attendance. This will be recorded. So we are going to dive quickly into a quick Q&A. So we'll circulate the webinar post-event. So if there's any, questions we answer that you are not able to stay on for, you'll be able to get the full recording. But let's just stay maybe another couple minutes while the chat window has a lot of questions. So first of all, I do appreciate the participation. So Ellen, I just let me turn the attention over to you. I have a question here, and I hope that you can help address. How does PKI fit into the overall space attempting to address IoT solutions today?
Overall space. All right, that's a good one. So I think about this a lot when I read different articles about things, or people send me notes about breaches and so on. And so when it comes to IoT security, there isn't one vendor or one solution out there that covers everything, and I don't think there ever will be. So what we recommend is that you understand the proper level of security that's required at each layer of your network stack, and design a security architecture that fits the policies of your company and whatever regulations are in your industry, whether that's medical or energy, so on. So for example, starting at the hardware level, pick a hardware vendor that has a secure storage of keys, some kind of secure element, TPM, for example. Pick the right kind of crypto libraries that have strong algorithms and the right level of encryption that you need. Pick a PKI vendor that can help you issue those trusted certificates, create that offline root of trust, segregate that exactly how you need it. Pick an IoT platform that helps you do the onboarding and device management, and then probably at the top level, like access control management and network infrastructure. So I think if you look at it that way and you start to think about all the different layers that you have, you'll get a better picture of the overall security requirements in your system. And that, again, just don't forget that key for authentication encryption is around the root of trust and establishing high assurance. So that's kind of how I would look at that one.
Thanks, Ellen. Alrighty, sifting through some of these questions. John, I hope you can help address this question. How do I get certificates to the device?
So there are several protocols for doing this. One that we have support for is called SCEP, where the device generates its own certificate signing request, packages it up, and then sends it to a server who then can sign it or pass it on to whomever signs it, and sends the certificate back to the device. And everything is signed with, public key. Everything's signed with public keys. So this you know, yeah, who signed it, and that it's actually from the device with that public key.
Awesome. Okay, great. Thanks, John. Appreciate that. Alrighty, so if you want to go to the next slide here. I would like to close today by thanking everyone for joining today's webinar. There were some questions that we were not able to address just due to time, but we'll make sure to circulate the questions with the team, and we'll reach out individually to ensure that your answer gets addressed accordingly. Thank you again. I hope everyone stays healthy and has a great day. Thanks, everyone.
Thanks. All right, take care.